We've all seen the incredible promise of AI agents, right? These autonomous systems that are supposed to plan, reason, and solve complex problems for us. But let's be honest, we've also seen them fail, and often in super frustrating, simple ways. So today we're going to look at two really cool new approaches that want to take AI agents from these kind of brittle, cobbled-together creations to something truly reliable, something engineered.
So, that really gets us to the big question. If these agents are supposed to be so smart, why do they break all the time? Why do they get stuck in loops or hallucinate facts or just completely miss the point of a task? There's this huge gap between their potential and how they actually perform.
And the core problem when you dig into the research is that we've been building them more like hobby projects than high-stakes engineering. It's all been a bit ad hoc, a bit trial and error, instead of using a disciplined architectural approach. And that lack of a solid foundation, well, that's exactly why they're so unreliable. Okay, so here's how we're going to break it all down. First, we'll look at AI's current growing pains. Then, we'll explore two massive ideas to fix them. The first is what I'm calling the architect's blueprint for building them right from the start. The second is a team debate process to help them learn from their mistakes. And then at the end, we'll see how these two ideas come together to build much, much wiser AI.
All right, first up, let's get really specific about what's going wrong. This idea of brittleness in today's agents isn't just one thing. It's actually a whole bunch of recurring failures that we really need to understand before we can even think about fixing them.
And these failures, yeah, they're probably going to sound pretty familiar. You've got agents that just make stuff up, hallucinations. You have others that get stuck in these dumb, unproductive loops, trying the same failed thing over and over. They can also suffer from something called catastrophic forgetting, which is just what it sounds like. They learn a new skill, and poof, an old one just disappears. And maybe the most important one, they're just not good at adapting when the world changes or thinking more than one step ahead. The key here is that these aren't just random bugs. These are deep, systemic weaknesses.
So, to fix these big, systemic issues, you need a systemic solution. And this is where our first huge idea comes in. We need to start treating AI agent design like actual systems engineering. Forget the monolithic black box. We need to think like an architect designing a really complex but modular system.
This framework is all about deconstructing the agent into 5 core interacting subsystems. You can see it here visualized as a set of nested layers. Each layer has a very specific job, which creates a clear separation of tasks, and that is a cornerstone of any good engineering. Let's just zoom in on the 2 most important layers, starting right at the heart of it.
So, at the very core, you have the reasoning and world model, or RWM. This is the agent's brain. It's this protected inner nucleus that holds the agent's understanding of the world, plans out strategies, and makes all the big picture decisions.
Then, wrapping around everything, you have the learning and adaptation layer. Think of this as the agent's ability to grow. It's the outermost shell that's always watching how all the inner systems are performing, learning from what works and what doesn't, and then sending feedback inwards to improve them over time.
Okay, so a good blueprint is absolutely essential. But architects don't just use blueprints, right? They also lean on standard, reusable solutions for common problems. You don't reinvent how to build the staircase for every single building. And for AI, this is where the idea of design patterns comes into play.
Exactly. Just like a building architect has a whole library of proven patterns, AI engineers can develop a vocabulary of what are being called agentic design patterns. These are just well-defined, reusable fixes for all those recurring problems we saw earlier, like hallucination or bad planning.
In this diagram, wow, it maps out the whole idea perfectly. Just follow the flow from left to right. On the far left, you've got a problem, like world modeling. The map shows you how that flows to a specific subsystem in the middle, in this case, the reasoning and world model. And then, finally, on the right, it points you to a specific design pattern that can solve it, like the integrator pattern. It's so elegant. Let's look at a couple of quick examples. The integrator pattern is designed to tackle hallucinations by basically creating a filter to check all incoming information before it can mess with the agent's brain. The controller pattern deals with value alignment by acting like an observer, constantly making sure the agent's actions stick to its core principles. And then you have the reflector pattern, which is all about learning from what happens. And this one is so important that it really deserves its own deep dive.
So let's zoom in on that idea of reflection. The ability for an agent to learn from its own mistakes is, it's absolutely critical. But the way it's usually done has a fundamental and kind of fascinating flaw.
So the reflector pattern is incredibly powerful. But here's the catch. What happens when the agent that made the mistake is also the only one critiquing it? It can become its own worst critic, or, even worse, its own biggest cheerleader, totally trapped by its own blind spots.
This is a pretty famous framework called reflection. Basically, an actor does something, an evaluator checks if it worked, and if it failed, a self-reflector writes up a little note about what went wrong. That note gets stored in memory to help it do better next time. It's a simple, elegant little feedback loop.
But there's a huge problem. As the researchers point out, this single-agent design leads to systematic shortcomings. You see, because it's the same model doing the acting, the evaluating, and the reflecting, it just falls into its own confirmation bias. It can't see outside its own flawed logic, which leads to really limited and often useless feedback. It's kind of like asking the person who got you lost to draw the map for the next trip. It's just not going to work well.
So, if a single agent can't reliably critique itself, what's the answer? Well, the breakthrough idea is to move from a monologue to a dialogue. It's time to assemble a team. And you can see the difference right here. On the left, you've got that simple, lonely loop of self-correction. But on the right, you have the evolution, multi-agent reflection, or MAR. Instead of one agent talking to itself, you have a whole team of critics and a judge. The process of learning from a mistake is no longer a quiet moment of reflection, it's a structured debate.
In this team, it's brilliant. Each member has a specialized role designed specifically to fight bias. You've got a skeptic whose only job is to question every assumption. You've got a verifier who fact-checks everything. You have a planner who's focused on the high-level strategy. After they all debate the failure from their unique angles, a judge steps in to combine all their critiques into one final actionable piece of feedback for the agent.
So, the million-dollar question, does it actually work? Well, the data here is incredibly clear. On a standard coding test, a baseline model gets it right about 67% of the time. Now, the single-agent reflection method boosts that to over 76%. That's a solid gain. But the team debate approach, MAR, jumps all the way to nearly 83%. So the takeaway here is that getting diverse critique from a team isn't just some tiny tweak, it is a significant leap in performance. And that brings us right to the end, where we can tie these two powerful ideas, the architect's blueprint and the collaborative team, together. Because they aren't competing ideas at all. They're really two sides of the same coin when it comes to building better AI. So, what's the big takeaway from all this? Building reliable AI agents really boils down to two things. First, you need the architect's blueprint, a really well-engineered system with clear parts and patterns to stop errors from even happening. And second, you need the team's wisdom, a diverse, collaborative process that lets the agent intelligently and effectively learn from the errors that will still, inevitably, happen. It's about being robust by design and resilient in practice.
And that leaves us with one last kind of mind-bending question. We've been talking about these as principles for humans to use when designing AI. But what happens when an AI system gets so advanced that it can apply these principles to itself? When it can be both the architect, designing its own mind, and the collaborative team, refining its own thoughts? What on earth will something like that be capable of creating?